Today we are going to cover section 8. It's on absolute value equations and inequalities. So let's go ahead and take a peek. Let's review what absolute value is. So if you recall from Algebra 1, absolute value is the distance a number is from 0. Absolute value will always be a positive number. So for example, if I said, what number could x be when it equals 5? So what number could I put in there to get a 5 out of that absolute value?
Positive or negative 5?
Beautiful. So when I absolute value 5, I get positive 5. When I absolute value negative 5, I still get positive 5. Because I want to know how far away is 5 from 0 and how far away is negative 5. So this is going to lead us up to why we create two different problems. Because I have to consider the negative and the positive. So here's my first example. Whenever you solve an absolute value inequality or an equation, your first step is always to isolate the absolute value. So sort of like when we solved the radical equations. Remember, we had to isolate the radical. So in these problems, we're isolating and making sure that the absolute value is on one side of the equal sign. Notice in this example, it's already isolated for us. Once it's isolated, I make two problems. I'm going to go ahead and drop my absolute value bars and set up an equation of 5 minus 3x equals 12. And then the other case that I need to consider is the negative. So I would also solve 5 minus 3x equals negative 12. So now I'm going to solve each one of these. And once I solve them, these are my answers. So negative 3x equals 7. Divide by negative 3. And x equals negative 7/3. Over here, subtract 5. Negative 3x equals negative 17. Divide by negative 3. Negative divided by negative becomes positive 17/3. So when it's an equation, we are not writing our answers in interval notation. We're just going to leave it as x equals. Now, on a standardized test, they might put it in the braces and show like this, but I'm okay with you just leaving it as x equals. So the only time we're using that interval notation is when it's an inequality, and that will be the next example. All right, so for the next example, I have the absolute value of 2x plus 1 is less than 7. So again, my first step is always to isolate the absolute value. It's already isolated. So now I need to make my two problems. Now, in addition to making that 7 negative, I'm also going to reverse the inequality symbol. So I'll go ahead and write my first problem that I'm going to solve as it is, just getting rid of the absolute value bars. And the second problem that I'm going to solve is I'm going to reverse the symbol and change the answer to negative. Because if you recall, when you divide by a negative, you're going to reverse the symbol. So now I'm going to solve each one. Negative 1, or subtract 1 from both sides. Divide by 2. And x is less than 3. I now need to solve the other one. 2x greater than negative 8, divide by 2, and x is greater than negative 4. Now, I need interval notation here, so let me go ahead and graph it, so that way I will know if it's just going to be the segment or if it's going to be the union. So if it's going to be the intersection or the union. So again, I'm going to put my numbers on here, least to greatest. I'm first going to graph this one. So x less than 3 would be an open circle going this way, or you could also show it's the parenthesis. Then this one, the open circle, and going this way. When you have an overlap like this, this is your answer. So when it's the overlap, remember your answer is just the negative 4, 3. Now, if the arrows were pointing with no overlap in opposite directions, that's when you're going to union the two answers. So in Algebra 1, your answer for this problem was just this. You don't have to graph in the homework. The way that you're going to write your answers is just in interval notation. Let's try the exact same problem, but I'm going to change it from a less than to a greater than. So again, isolate the absolute value first, and then make the second problem, flip it, and make it negative. Solve for x. 2x is greater than 6. Divide by 2. X is greater than 3. Over here, subtract 1. Divide by 2. And x is less than negative 4. Again, let's graph these. So this one, let me put my numbers on here, least to greatest. So negative 4, positive 3. So for this one, open on 3. For this one, open on negative 4. So for this one, and again, you can see that this is negative infinity here, positive here. So for this solution, you would write it as negative infinity up to the negative 4. You're going to union it with this gap here. So jump over there, and then you would go from 3 to infinity. So the solution set consists of the green side and the blue side. So either side would provide an answer to this absolute value. The numbers we're getting when we solve for x are cutoff points. Let's try the next example. What do I need to do first? Beautiful. Isolate that absolute value first. The mistake that my Algebra 1 students make is they jump right into the two problems without isolating, and then they get the wrong answer. So we need to move the 1 first before we can make our two problems. Now that the absolute value is isolated, now I can solve my two questions. So 2 minus 7x greater than 5, and 2 minus 7x, flip it, and negative 5. Go ahead and solve for x. Divide by negative 7. Here we go with that simple inequality stuff. Remember, when you divide by a negative, we need to reverse that symbol and make it a less than. Over here, subtract the 2. Negative 7x is less than negative 7. Divide by negative 7, reverse, and we get positive 1. We'll now graph each of the simple inequalities on our number line. Again, put the numbers on here least to greatest. This one will be an open circle, everything less than negative 3/7, and then here, open circle going in this direction. So now to write this in interval notation, we're going to write from negative infinity up to the negative 3/7. We're going to union that with the red, which goes from 1 to infinity. When you just have numbers involved in your absolute value inequality, they're easy. You isolate, you solve the two problems, and then you write your answer. Now, there is some special cases with absolute value. Remember, absolute value can never be a negative number. So, for the example, again, same process, make sure it's isolated, but a red flag for you guys, as soon as you see that your absolute value involves a negative number, you need to stop and you need to think about what's happening here. So whenever this number is negative, if it's greater than a negative number, then you know it's going to be, it doesn't matter what x is, it's going to be always true, because you will always get a number out of absolute value that is greater than -4, because it's always going to be positive. So when this occurs, if this is a negative number here, then you got to stop. If it's greater than the negative number, then the answer is all real numbers. And you would represent all real numbers with interval notation from -infinity to +infinity. This is all real numbers. Now, let me show you how potentially I could trick you. Okay, so let's say we have a question like this. 2 minus 5x greater than or equal, well, no, let me change this. Plus 5, no, minus 5, sorry. Minus 5 is greater than or equal to -4. Now, red flag, right? It's got a negative there. But what is your first step? Isolate. What happens when I isolate? What happens to that negative number? And now I can actually solve this thing and make the two problems. Okay, so be careful. Okay, you should be looking for that negative number as the answer. And then if it's negative, stop and think, wait a minute, is it already isolated? Can I just say all real numbers? Now we're going to look at the flip of that. So let's look at the next example. Now we reversed it, and now it's less than a negative number. Will I ever get a number that's less than -3 out of my absolute value? Never, right? Because it's always positive. So for this one, when it's less than a negative number, then it's no solution. Yes.
So when there's negatives in it,
Yes.
the underline under the greater or less than, this just never matters?
It will. It won't matter as far as brackets or parentheses, but in the last example that I do, we're going to see one. But it'll be a 0, I think.
Angelina Teta reports to services. Angelina Teta reports to services.
All right. So when it's involving a 0, it's not going to matter. Does that make sense? But actually it will. Sorry, I got to take that back. So when it's less than or equal to, it will matter. And we're going to cover that example in a minute. But as far as the brackets go around the numbers, around the infinities, there are always parentheses for this. All right, but this one was no solution because I will never get a negative number out of an absolute value. Let's look at the case of an equation, an absolute value equation that's set equal to 0. Remember when this was a number instead of a 0? We made two problems, right? But do I have positive and -0? No, right? So for this one, I'm only going to have one solution. I just take away the bars and solve it one time, because I'm not going to set it equal to +0 and -0. So subtract 15. So 5x equals -15. Divide by 5, and x equals -3. So again, when it's an equation, no interval notation. Now, here's what Cy was talking about with this greater than or equal to on the next slide. So we just saw when your absolute value was less than a negative number, it was no solution, right? Now, this symbol here, less than, so this really means less than or equal to. That's what that symbol really means. So now I need to take care of both situations. So if I were to do 3x plus 2 is less than 0, what would happen there? What would I get? Will I ever get a negative number out of that? So this part of the problem is no solution. But I still need to do the 3x plus 2 equals 0. So I have to do a problem for the less than and for the equal to part on this one. So now I'll subtract 2. 3x equals -2, divide, and x equals -2/3. So for this one, now if it were just a plain less than, it would be no solution. But because I have less than or equal to, I have to find the value that would work, and that would be -2/3. Yes. So for this answer, you're just going to list it as the -2/3. Let's try one more example. All right. So out of this one, at first glance, you're going to think, wait a minute, I'm always going to get a number greater than 0, correct? So you might think, wait a minute, it's all real numbers. However, when this thing equals 0, it wouldn't work. So for this problem, I have to figure out what wouldn't work. So I'm going to take 4x plus 3, set it not equal to 0. This is what x cannot be. And I'm going to show you after I solve it what happens. So subtract 3 is, if this is equal to 0, is this a true statement?
No.
No. So this is why I got to find out what the value of x would make that thing equal 0. Does that make sense? Because that's the answer I'm going to throw out. Okay, so there's going to be one number I throw out. All the rest of the solutions for x work. Because technically, if you look at this at first glance, you know that when you absolute value something, it's always positive. So if I'm trying to look for a number that's greater than 0, it doesn't matter what I put in there for x. I'm always going to get a number bigger than 0. But the one time that it won't work is when that value that's in that bars is set equal to 0. Okay, and I'm going to figure out what that number is going to be. Divide by 4. So x cannot equal -3/4. Because watch what happens when it does. So if I take -3/4 and plug it in, four times -3/4 is -3. -3 plus 3 is 0. When I absolute value 0, I get 0. Is 0 greater than 0? No, it's not. So this doesn't work. So I had to figure out what number would not make that inequality true. So the only number that doesn't work is -3/4. Now the way that I'm going to graph this, because all the other numbers work, it's all real numbers except when x equals that. So here's how we're going to graph it, or how we're going to write it. So here's my all real numbers. So it should be this whole thing. And if I put -3/4 here in the middle, I'm going to make a little hole. And then I'm going to make my graph go all the numbers except for that little hole in my number line. And the way that we would write this is from -infinity up to -3/4, union that's the hole, and then start it up again. So it's like coming along here, hitting this, jumping over it, and then keeping and going. So you need to stop and think when your absolute value is got a 0 involved and when it has a negative number involved. All the other ones, you're going to make your two problems and solve them. Okay, so your homework is these problems. Again, every other odd. So if it helps you to write out the numbers, 27, 29, 31, 33, and then go back through and cross off the every others, you can do that.